Okay friends, welcome back to my channel. In this video we will do some practice questions on quadratic function. If you watch my other video, you would see that the parabola opens up. First of all, let's talk about the standard format. Y equals ax2 plus bx plus c, and then a, it's always the coefficient of x to the power 2. B, it's always the coefficients. They are called coefficients. And then B, it's always the coefficients of x. And C, it's always the constant. And the shape of a parabola would always be like a U. And if A is a positive number, it would open up. But if A is a negative number, it will open down. So it will open up, but if A is 0, it will open down. Okay, and then we also know that if absolute value of A, it's less than 1. So if A, once more, if the absolute value of A it's less than 1, the shape of the parabola would be wider than the graph of y equals x to the power 2. Okay, so it would be wider. Okay, but if A, it's let's put it this way, sorry, greater than 1, it would be narrower. Sorry about it. Okay, and just to remind you, this is y equals x to the power 2, and it's the simplest form of a parabola. The b and c are equal to 0, but still you can see that the a, it's 1, and then if I want to graph it roughly, it would be something like this. It would be an upward U, which the vertex, it's exactly located on a 0 and 0. So there is still a line of symmetry. Okay, but if the absolute value of A is less than 1, your graph would be wider than this. And if the absolute value of A is greater than 1, your graph would be narrower than this. Let's try to do a few examples together. So in this example, we have 2 times x to the power 2, negative 8 to the power negative 8 times x plus 6, and we want to graph it. So let's start with defining or identifying our a, b, c. A, b, c. So the A is 2, the B is negative 8, and the C is 6. And remember, the X would be negative B over 2A, which is your line of symmetry, and it would be negative 8 over 2 times A over 2 times 2, which would be 8 over 4, and it equals to 2. Here, as you can see, the A is greater than 0 and it's a positive number. So you would know that the shape would open up, right? This is the first thing you definitely know. The vertex would be the minimum point or at the lowest level. And then here we know that the vertex x value would be 2. Then we will be using this x value, we can substitute it back in our original formula and find the y coordinates. Okay, so here y would be 2 times 2 to the power 2 minus 8 times 2 plus 6, which the answer would be negative 2. Okay, so here the vertex would be located exactly at 2 and negative 2. Okay, now using our information, let's draw the graph. Okay, so this is your x-axis, and where is your vertex located? It would be at 2 and negative 2. So let's say here I put it somewhere around, let's say I put the y-axis here as well. Okay, and then I will put the vertex, which is at 2 and -2, and then the line of symmetry, which is here, okay? And then remember, now we have to find a couple of points, and then using the line of symmetry, we can find the other half. So we continue by finding 2 points on one side of the axis of symmetry. Let's start by x and y. We give the x, let's say 1. Let's start by 1 is a better number. So we give it 1, and the value of y, if we substitute it in the original equation, would be 0. And then let's say, yeah, even 0 would work. If we give the x value as 0, the y would turn out to be 6, and both of this point would be at this side of the graph. Okay, so one point would be 1 and 0. 1 and 0. The other one would be 0 and 6. Let's say it would fall here. Okay, so this one would be 1, 0. The other one would be 0 and 6. And then I try to connect all the dots on one side very smoothly. Sorry, it should be passing through this point. Okay, so now it should be perfect. Sorry, so it would be something like this. And then from here, I know that it should be symmetrical, so it goes something like this. And if you want to calculate these points, these 2 points would be exactly on 3 and 0, and this point, which is similar to this, would be located at 4 and 6. Okay, sometimes our function is not in a standard format, and your function would appear something like this. So you would have a constant times parentheses x minus h to the power 2 plus k. In this case, then your vertex would fall exactly on h, which is this one, and k, okay? And then the axis of symmetry would be on x equals to h. So whenever they give you a quadratic function and they want you to graph it or find vertex or axis of symmetry, first of all, you have to identify, is it the standard format or is it the non-standard format? If it's the standard format, then you use the formula for the standard format, which is finding the line of symmetry would be x equals b minus negative b. Okay, remember I put up the slide from the previous time. If it's the standard format like this one, okay, so the line of symmetry would follow this formula, which is negative b over 2 times a. Then you identify a, b, c, you just substitute it and find it. Okay, this would be the x value of the vertex. You find the x. After you find the x value, you substitute it back in your original formula, and then you find the y value of the vertex. Okay, and if you refer to my previous video, there are a couple of examples which I solved for you, but sometimes it's not in a standard format, so we use these 2 formulas. The vertex would be on h and k, and then the axis of symmetry would be x equals h. Let's do a couple of examples. So here in this example, which is not in the standard format, the value of the a, it's negative 1 over 2. The value of h is negative 3, and the value of k, the value of k is 4. And then we also know that the a, remember the a was the coefficient of x to the power 2. So here the a is less than 0, So we definitely know that the parabola will open down. So it would be a downward U shape, okay? And then the vertex would be the maximum or the highest point. Okay, so let's start by finding the vertex. In order to find the vertex, so we have to find the coordinates, okay? And we follow this formula, which is H and K. So here the vertex would fall exactly on -3 and 4. And the line of symmetry, as always, would passes through the vertex. So let's draw the line of symmetry. Okay, so this is your line of symmetry, and then you have the vertex. And then in order to find points which give you a nice kind of perfect graph, you better find a couple of points either on this side or on this side, and then using the property of symmetry, then you can reflect it and find the other side of the equation. So what I do here, I would try to find 2 points on this side and then find the values of x and y, and then reflect and use the line of symmetry and reflect on the other side as well, and finish my graph. Okay, so x value, I give values to x and I find the y value. I give the x 1 and substitute it in my formula. So instead of x, I put 1. So 1 plus 3 would be 4. 4 to the power 2, it's 16, times -1/2, which would be -8 plus 4. The final answer would be -4. But if I substitute, let's say I give -1, and if I substitute x as -1 here, so this one turns out to 2. 2 to the power 2 is 4. 4 times this one would be -2. -2 plus 4 would turns out to be +2. Now let's put the points on my graph. So let's say here it would be -1 and 2, and on this side, let's say it would be 1 and 4. And let's draw the x-axis, the y-axis as well. So we would know that the y-axis, so if it's the x-axis, it will pass somewhere around here, and then the y-axis would be somewhere around here. Again, it wouldn't be a perfect thing, but then if I want to find the other points on this side using the symmetry, then these 2 points will fall on -5 and 2, and the other one would be on -7 and -4. So this is basically the same thing. The steps are the same. The only difference is that because here you don't have the standard formats and you have a different format, you have a different formula for the vertex and you have a different formula for the axis of symmetry. And then other than that, the rest of the steps is the same. You identify A, H, K, and then you find the vertex coordinates. You take a look at the A value. Is it positive, negative? Does it open up or open down? And then you find a couple of points on one side of your graph, and then you do it. And then using the line of symmetry, you can graph the other side of your graph. Okay, I will continue this video with another form of non-standard quadratic function. As you can just again to remind you, this was another type of non-standard format, and now the third one, this format. Okay, as you can see, these are both non-standard and they are different. Okay, in this format, let's say the x-intercepts, okay, the x-intercepts, that's when they meet the x-axis. So the x-intercepts are P and Q. And then the axis of symmetry, okay, the axis of symmetry would be halfway between these 2 points, okay? So this is point number 1. This is another point. So your axis of symmetry would be halfway in between. All right? So now let's do a couple of examples. Y equals. So in this example, our equation is y equals negative, which what I mean is -1 times 2 parentheses. So the first parenthesis is x plus 2. The second parenthesis, it's x -4. And if you compare it with the original non-standard format for the quadratic, you will see that the a value would be -1. The p value would be -2, and the q value would be 4. And here, the a value, which is the coefficient of x to the power 2, it's less than 0. So a value, it's -1. And some of you might ask yourself why. So let me explain it to you. So here, if I want to simplify it, I have to multiply these two together. In order to do multiplication, if I want to do step-by-step multiplication, which is a good practice actually, so this first term should be multiplied by the second parenthesis, and then the second term should also be multiplied by the second parenthesis. So let's do it together. X times x would be x to the power 2. X times -4 would be -4x. And then 2 times x. The other one would be 2 times -4, which is -8. If I want to simplify it further, and if I want to simplify it, that would be x to the power 2. These two would add into -2x, -4. And then don't forget about this small negative sign in here, so it will change the whole story. It will be multiplied by all the 3 terms inside the parentheses and change the sign. So it would be -x to the power 2 plus 2x and plus 4. So your final function would be something like this. And as you can see from here, your a is equal to -1, which is less than 0. So from here, we would know that our function would be downward. So, or in other words, it will open downward. Okay, so let's try to graph it together. I wrote down the function again. This is not a standard format, and I will go step by step. The x-intercept, as we know, would be at -2 and 0 and 4 and 0. So the x-intercept, I put it here, it would be at -2 and 0 and then 4 and 0. Okay, so let's put it on the graph. So if this is 0, that would be -2 and 0. And the other side would be this much and this much, 4 and 0. These are the two x-intercepts, sorry. Okay, now the line of symmetry, as I mentioned, would be somewhere halfway, exactly halfway through these points. So from -2 to 4, the distance is 6 units. So I have to move 3 units. So 2 units here, and let's say 1 unit here. So my line of symmetry would be something like this. Okay, so it needs to be in a straight line. Sorry, I'm not good with doing a straight lines. So the other thing is that we calculate the a value and it was a negative value, so we know that it would open down. Now let's do, we could also say, so this is halfway through here, so the x value here would be exactly as 1. Okay, so we found the x as 1, and it's exactly, this is the x coordinates of the vertex, and we know that the vertex should be somewhere around here. So we will substitute the x value in our original formula and we find the y value. Okay, so here y would be negative x is 1 plus 2 times 1 minus 4, and it turns out to be 9. Okay, so the good thing is that the vertex would be located as 1 and 9. Perfect. And now what I can do, I better find another point on either side, either this side and this side, and then connect the dots, and using the symmetry find the other half. So for me, it would be easy to find, so let's say in order to find one value, x and y, I give the x as 0 and then substitute it here, so 0, 0. So the final value would be plus 8. Okay, so I know another point would be on 0 and plus 8, so somewhere around here. Okay, 0 and plus 8. So simply I just connect them together. Hopefully I'll be, and it's a downward thing, so I'll do the same here if I want to be exact. So this one, this would be exactly an 8, and I have to connect it to here. Okay, and this is your shape. And if you want to find the x value for this point, you can do it like this. So here, this point is exactly 1 unit away from the line of symmetry. So here, it should be the same. So it's 1, we add another unit, and it falls on 2. Okay? If you want to make sure you found the correct value, just substitute it back and make sure you are on the right track. So let's say I substitute x as 2 in this formula and make sure the y value is equal to 8. So let me try to squeeze it in here. So that would be 2 plus 2, and then it would be 2 minus 4. So that would be 4 minus 2. This turns out to be 4. This is minus 2. So 4 times minus 2, it's minus 8. And then we have a negative sign here. So the answer would be plus 8. Yay. I hope you enjoyed this video. Please don't forget to subscribe to my channel, and write down in the comments if you need any question, any specific question to be solved. Thank you.